Germany held in its hands the car of the future in 1953, but the industry decided to bury it forever because it did not generate enough immediate profit. Before we begin, let me know in the comments where you are watching this video from, so I can see how far it has reached. The cold morning air passed through the broken windows of what had once been a weapons factory in North Rhine-Westphalia. Now, in that same space, a group of German engineers worked silently over technical sketches and polished metal parts. Outside, German cities still bore the scars of the war: destroyed buildings, half-rebuilt streets, an entire nation trying to rise from the rubble. It was the year 1953, and West Germany was in the midst of reconstruction. But while most factories raced to produce mass consumer goods, to make up for lost time, to show the world that Germany was once again an industrial power, this small team was pursuing something different. They did not want to build the fastest car, nor the most luxurious, nor even the cheapest to buy. They wanted to create the most efficient car ever built. Post-war Europe had brought with it a paradox. On the one hand, the need to quickly rebuild the economy drove mass production. On the other, resources remained limited. Oil, although beginning to flow more abundantly from the Middle East, still represented a dangerous dependency for a devastated continent. In that context, some visionaries understood that real progress was not about consuming more, but consuming better. That recovery should not only be measured in units produced, but in the intelligence with which available resources were used. And in the industrial heart of Germany, that vision took shape in metal, rubber, and technical genius. The informal leader of that team was a man named Klaus Dietrich, an engineer who had worked during the war developing engines for the Luftwaffe. Dietrich was a quiet man, with a piercing gaze and grease-stained hands, even when wearing a suit. He had seen how technology could be used for destruction, and now sought redemption by creating something useful, something that would improve the daily lives of ordinary people. His obsession was simple but radical: to design a car that could travel 100 kilometers with less than 3 liters of fuel. In a time when average cars consumed between 10 and 15 liters per 100 kilometers, that sounded like science fiction. But Dietrich was not alone in his quest. Alongside him worked Friedrich Baumann, an aerodynamics specialist who had studied the shapes of military gliders; Greta Hoffmann, one of the few female engineers of the time, an expert in lightweight materials; and Otto Kraus, a brilliant mechanic capable of building engines from scratch with recycled parts. Together, they formed an unconventional team, brought together more by passion than corporate directives. Their project had no official backing from any major manufacturer, although they received modest funding from a consortium of small companies interested in exploring alternative technologies. The first challenge was conceptual. In those years, the automotive industry clung to designs inherited from before the war. Cars were heavy metal boxes, with oversized engines and no real consideration for air resistance. The prevailing idea was that more power meant a better car, and that weight was a secondary problem solved simply by adding a bigger engine. Dietrich and his team knew that approach was a dead end if the goal was extreme efficiency. They needed to rethink the car from scratch. The process began with weight. Greta Hoffmann proposed using aluminum and magnesium alloys instead of traditional steel. These materials were more expensive and difficult to work with, but offered a dramatic weight reduction. They calculated they could build an entire chassis weighing less than 200 kilograms, a fraction of the weight of conventional vehicles. Every component was examined, redesigned, lightened. Seats were made with tubular frames and sturdy canvas. Windows were made thinner. Even bolts and screws were selected for their strength-to-weight ratio. At the same time, Friedrich Baumann worked on the vehicle's exterior shape. He spent hours in a small, improvised wind tunnel, testing clay and wood models. He discovered that most cars of the era had terrible aerodynamic drag coefficients, wasting energy simply by pushing air inefficiently. Baumann designed a teardrop-shaped body, with a gently tapered rear, partially covered wheels, and minimal ground clearance. The result was a vehicle that seemed from the future. Smooth, organic, almost alien compared to the square and aggressive lines of contemporary cars. Otto Kraus faced perhaps the most complex challenge: the engine. Engines of the time were powerful but extremely inefficient, with huge losses due to friction, heat, and incomplete combustion. Krauss decided to start with a simple air-cooled two-cylinder engine. He reduced displacement to barely 400 cubic centimeters, a fraction of what was considered normal. But he compensated for that small size with meticulous engineering. Lightweight pistons made of special alloy, precise injection system, optimization of the combustion chamber to extract every possible calorie from the fuel. The engine produced only 18 horsepower, but in a car weighing less than 300 kilograms in total, it was more than enough. The final prototype was assembled in the winter of 1954. It was a two-seater vehicle with smooth silver lines, panoramic windows, and a minimalist but functional interior. It looked like an egg on wheels, and factory workers watched it with a mixture of curiosity and skepticism. But when Klaus Dietrich turned the key for the first time and the small engine came to life with a soft, almost inaudible purr, something changed in the atmosphere. There was anticipation. The first tests were conducted on secondary roads in Rhineland, away from prying eyes. Dietrich drove personally, with Baumann alongside taking notes. The car accelerated slowly but steadily, reaching a maximum speed of 90 kilometers per hour. It was not a sports car, but it did not aim to be one. The extraordinary thing came when they measured consumption. Under normal driving conditions, the prototype consumed barely 2.5 liters per 100 kilometers. In extreme economy tests, driving at a steady speed of 50 kilometers per hour, they managed to reach figures below 2 liters. It was something never seen before. News of the prototype began to circulate discreetly in technical circles. Some engineers from major manufacturers visited the facility, observed the tests, examined the plans. There was professional recognition, even admiration. But there were also doubts. Would the public really want such a car? So small, so austere, so different? Was the market ready to prioritize efficiency over status and power? In 1955, the team presented their work at a technical conference in Stuttgart. The presentation was detailed, rigorous, backed by extensive test data. They showed how their approach could drastically reduce operating costs for drivers, decrease dependence on imported oil, and lay the groundwork for a more sustainable automotive industry. They received polite applause, formal congratulations, but also silence from the big corporations. Because while Dietrich and his team worked on their vision of extreme efficiency, the German automotive industry took another path. Manufacturers like Mercedes-Benz, BMW, and the emerging Volkswagen bet on larger, more comfortable vehicles with more powerful engines. The German economic miracle, the Wirtschaftswunder, was in full swing. People wanted to forget the years of rationing and scarcity. They wanted cars symbolizing prosperity, not austerity. Oil from the Middle East flowed cheap and abundant. The highways were expanding. The future seemed limitless. Executives of the big brands analyzed the low-consumption prototype with cold business logic. They recognized its technical merit, but saw insurmountable commercial problems. The car was too small for families. It lacked the prestige of traditional models. Its production required specialized techniques and materials that increased costs. And most importantly, its profit margins would be much lower than those of conventional vehicles. A small, efficient car could sell at a good price initially, but the industry made money on volume, accessories, and the perception of added value. An austere, functional vehicle did not fit that equation. There were discreet meetings between industry representatives and government officials. The future of the German automotive industry in European reconstruction was discussed. Strategies of international competitors were analyzed. The conclusion was unanimous. Germany had to compete in the global market with high-quality vehicles, superior engineering, and brand prestige. Experiments with extreme consumption were interesting as technical exercises, but not as an industrial strategy. In 1956, funding for Dietrich's project was canceled. Officially, it was argued that resources should be concentrated on initiatives with greater immediate commercial potential. The prototype was stored in a warehouse. The engineers were reassigned to other projects or hired by large companies where their talent would be channeled toward more conventional goals. Klaus Dietrich accepted a position in the development department at Mercedes-Benz, where he would work on diesel engines for luxury vehicles. He never again attempted to build an extreme consumption car. Greta Hoffmann left the automotive industry and dedicated herself to university teaching, where she trained a new generation of engineers with a more holistic vision of design. Friedrich Baumann worked briefly in the aerospace industry before retiring early, disillusioned with the direction commercial engineering was taking. Otto Kraus opened a small motorcycle repair workshop on the outskirts of Dusseldorf, where he applied his efficiency knowledge on a craft scale. The prototype remained forgotten for decades. Occasionally, an automotive historian or specialized journalist would stumble upon references to the project in technical archives. But the official history of the post-war German automotive industry did not include chapters on failed experiments with extreme efficiency. The dominant narrative celebrated spectacular growth, conquest of international markets, the triumph of brands that became symbols of precision engineering and social status. Meanwhile, the global automotive industry followed the same path. Cars became bigger, heavier, more powerful. Fuel consumption steadily increased. Cities were designed around cars. Highways multiplied. Oil seemed inexhaustible and its price forever low. Efficiency was a marginal criterion, mentioned in technical brochures but rarely decisive in purchase decisions. It was not until the oil crisis of 1973 that the questions Dietrich and his team had posed 20 years earlier became relevant again. Suddenly, with fuel prices skyrocketing and supplies uncertain, efficiency became a priority. European and Japanese manufacturers began developing smaller, more economical vehicles. But by then, 2 decades of development had been invested in the opposite direction. Infrastructure, consumption habits, market expectations, all were set for big, thirsty cars. Some veteran engineers then remembered the German prototype from the 50s. They searched archives, traced documents. They found that many solutions now presented as innovative had already been explored and proven functional decades earlier. Lightweight construction, optimized aerodynamics, small efficient engines, all existed in working form in 1954. But the opportunity to make it an industrial standard had been lost. Klaus Dietrich, by then retired, was briefly interviewed by a technical magazine in 1975. He was asked if he felt vindicated by the oil crisis, if he believed his project could have changed the industry's course. His answer was measured but melancholic. He explained that the problem had never been technical but about priorities. The technology to build efficient cars had existed for decades. What was lacking was industrial will and market demand. The oil crisis had not fundamentally changed that. It only added a temporary economic incentive. Once prices stabilized, he predicted, the industry would return to its old habits. And to a large extent, he was right. During the 80s and 90s, with oil prices again low, vehicles grew in size and power once more. SUVs and pickups dominated the North American market. Even in Europe, where fuel taxes kept prices higher, the trend was toward larger, better-equipped vehicles. Efficiency improved gradually thanks to technological innovations, but those improvements were used to add power and performance, not to dramatically reduce consumption. The German prototype from 1954 was finally rediscovered in a municipal warehouse in 2003. A group of classic car enthusiasts found it while researching experimental post-war vehicles. It was in surprisingly good condition, protected from rust by the dry warehouse climate. It was carefully restored and exhibited at the Stuttgart Automobile Museum as a historical curiosity. Museum visitors stopped before it with expressions of surprise. They read the technical specifications: 2.5 liters per 100 kilometers, 300 kilograms weight, aerodynamic design. Many commented it looked more modern than vehicles from decades later. Some young engineers studied the available plans, marveling at the elegance of the technical solutions. But few truly understood the historic opportunity it represented. Because Dietrich's prototype was not simply an efficient car, it was proof that another path was possible, that the automotive industry could have developed from the 50s onward with efficiency as a fundamental principle, not as a feature added under external pressure. That decades of technological development and trillions of liters of fuel could have been saved if industrial decisions had prioritized energy rationality over unlimited growth. The question the prototype posed was uncomfortable. How much real progress was lost by choosing the path of increasing consumption? What would the world be like if efficient cars had become standard in the 60s instead of waiting until the 21st century? How much pollution, How many carbon emissions, how many geopolitical conflicts over oil could have been avoided? There are no definitive answers to these questions, only speculation. But what is verifiable is that the technology existed. Brilliant engineers demonstrated its viability, and that the decision not to develop it was not technical or scientific, but economic and cultural. It was a conscious choice to prioritize short-term profits over long-term sustainability, to favor immediate growth over strategic prudence. The story of the extreme low-consumption German prototype is also the story of how industrial societies make technological decisions. They are not neutral processes guided solely by technical logic. They are deeply influenced by structures of economic power, cultural expectations, institutional inertia. A superior technology does not impose itself automatically. It needs favorable social and economic conditions to develop. In the context of the 50s, those conditions did not exist. Post-war culture prioritized visible growth, rapid recovery, demonstration of economic vigor. Efficiency sounded like scarcity, limitation, rationing times everyone wanted to forget. The big, powerful car symbolized regained prosperity and freedom. The small and efficient car, no matter how technically ingenious, did not fit that collective imaginary. Engineers like Klaus Dietrich understood this intuitively, though it frustrated them. They knew their battle was not only technical, but cultural. And on that ground, they were at a clear disadvantage against the power of marketing, economies of scale, and the ideological drive of an era that celebrated consumption as liberation. Decades later, in a world facing evident planetary limits, Dietrich's perspective seems prophetic. The idea that resources are finite and must be used intelligently no longer sounds like pessimism, but basic realism. Modern electric cars recover some principles of the 1954 prototype: lightweight construction, optimized aerodynamics, energy efficiency as the primary goal. But they arrived 70 years late, after trillions of tons of carbon were emitted into the atmosphere. The German prototype remains in the museum as a silent witness of a future that was not. Visitors photograph it, read the explanatory plaques, perhaps briefly reflect on roads not taken. Then they leave the museum and get into their SUVs, their 2-ton sedans with engines that would have seemed obscenely oversized to the engineers of 1954. The irony is evident, but rarely acknowledged. The modern automotive industry prides itself on improvements in efficiency, every fraction of a liter saved, every gram of emissions reduced. But those advances are incremental, built on a foundation of structural waste that could have been avoided from the start. It is like celebrating efficiency improvements on a ship while ignoring that the course chosen decades ago leads directly toward an iceberg. Klaus Dietrich died in 2007 at the age of 92. Until the end, he maintained his interest in efficient engineering, following developments in hybrid and electric vehicles with a mixture of satisfaction and melancholy. In one of his last interviews, he said he would have liked to live long enough to see 2-liter cars per 100 kilometers become standard, not a rarity. He died before that happened, and it will probably be years before it does. His legacy, however, remains. Not in the form of commercial patents or mass production models, but as a reminder that technical progress is neither linear nor inevitable. Societies choose which technologies to develop and which to ignore. And those choices, apparently technical and neutral, have consequences extending for generations. The first extreme low-consumption car did not fail due to technical limitations. It failed because the industrial society of its time was not prepared to accept its implications. Because it questioned the unlimited growth model that defined post-war progress. Because it suggested that maybe there were limits to respect, efficiencies to seek, uncomfortable questions to answer. Today, 7 decades later, those questions remain without satisfactory answers. Cars are marginally more efficient, but infinitely more numerous. Technology has advanced, but total energy consumption for transport continues to grow. The solutions Dietrich and his team demonstrated in 1954 are finally being implemented, but in a world already decades late in the energy transition. The next time you see a modern car proudly advertising consumption of 4 or 5 liters per 100 kilometers, remember that German engineers achieved half of that with 1950s technology. The question is not what we can do now. The question is what we could have done if we had started 70 years ago, and why we chose not to.